Greetings, users of internet, and welcome back to Minecraft. I am Dave, the Angry Jew, and this is my very first Minecraft lab, lab number 1, the properties of redstone. As you can see, I am all geared to go for our lab experiment. I've got my nice protective lab coat, and I've got my special safety goggles. Make sure we're always protected when doing experiments in the lab. Let's get started. This is my lab surface, my workstation. I went ahead and made this in MC Edit. It is a nice big flat area that I've gridded out. And it's gridded for a couple reasons. One, because it looks fancy. And two, because as I start doing larger builds, it's easier to approximate sizes because each of these squares is exactly one chunk, 16 by 16, including the border. So it's easier to approximate sizes when we start doing larger objects, things like that. But for now, we're dealing in the very small. This is redstone. I'm going to assume that most of you have no idea how to use redstone because that's why you're watching my tutorial video. Redstone is incredibly expansive. You can do tons and tons of stuff with it. But before you can do anything with it, you have to understand how it works. A lot of redstone tutorials dive right into logic gates, which is what's over there, and what I will cover in my next lab, the redstone logic gates lab. But before you can do logic gates, I feel you really need to just understand how redstone works. And a lot of people that are trying to build stuff with redstone don't know how it works. The idea behind my approach is that if I show you how to use the redstone first, before we do the logic gates, you'll understand why the logic gates work. And that way you won't need to be constantly watching my video over and over and over again to copy my design into your world. If I teach you how the redstone works, you'll be able to come up with your own creations, come up with your own designs. That being said, I will later do labs where I give you designs that you can copy and paste. But I feel that it is my job as a teacher to give you an idea of how the substance works in and of itself, and you can play around with it on your own outside of class, so to speak. So without further ado, we're going to get started. There are many things to talk about with redstone. We're going to start at the very basics, because I'm going to assume that since you're watching my video, you don't know anything about redstone. There are 4 different kinds of blocks that hold or transmit power in some way. The first one is, of course, the redstone torch. And each of these, besides this block on the end, have an on state and an off state. Although, I guess technically the block does have an off state, so I'll put that one there. Each of these blocks has an on state and an off state. We'll get to the solid blocks later. But the first one is the torches. Torches transmit power in all 4 directions, and we'll get to the details of each of these things later. Torches generally transmit power, and they're almost always on, and they just send power out. There's an on-state torch and an off-state torch. Redstone dust, or redstone wiring, as a lot of people call it, also has an on and an off state. It transmits power in all 4 directions, but it does not emit power of its own the way a torch does. Repeaters transmit power in exactly one direction and only receive power in the opposite. So it receives power in the direction that is behind the arrow, so back here, and it sends power in the direction of the arrow, so this way. And there's again an on state and an off state. I had to do some wiring just to put a torch underneath here to get this to turn on, because the redstone, the repeater does not receive power from underneath, so I couldn't really hide it. I had to do this. And then there's again an on state and an off state. And of course, the thing that most people overlook is the block itself. Just any kind of material block does transmit redstone power. The difference is it only transmits power for one block. It will not go through the block. This block is powered right now, but I can't take power from that block in any way. I can get power from the top, and that is it. And the only reason I can get power from the top is because this wire is powered. There's a way to utilize this in what I call a circuit breaker, which, in all honesty, has no practical application unless you're doing really compact redstone stuff. But it is important for certain things to keep in mind that this block is powered, and you can get power transfer in weird ways if you don't pay attention to the way the blocks are behaving. Those are the 4 kinds of redstone transmitters. There are also 4 kinds of, well, those are the 4 kinds of power transmitters. There are 4 kinds of blocks that apply power to a redstone system. The first of which we already mentioned is the torch. It does send power out from itself. It generates its own power. The other 3 are levers, pressure pads, and buttons. Levers will transmit power as long as the lever is pulled down. Down is the on state, up is off. The next one is the pressure plate. There are two kinds of pressure plates. There's also a wooden one, which I don't have out yet. I should probably put one down. Here's a wooden pressure plate. And a wooden pressure plate will transmit power as long as any object at all is on top of the pressure plate. Why can't I drop this? Oh, because I'm in creative mode. As long as any object at all is on top of the pressure plate, this wooden one will transmit power. Stone does not transmit power from any old object. It has to be a player or a mob standing on the pressure plate to transmit the power. And it will transmit power as long as there is a person on the stone plate or anything on the wood plate. I can't actually place a block on top of the plate, though. It doesn't work like that. The third and fourth, including the torch, and last one is the button, which is used for pulses. I push the button, and you'll notice that the power is transmitted as long as the button is depressed, and it eventually releases itself. I can continually press this button and try and get a steady pulse, but the general idea is that buttons are used for a one-time pulse, and that has applications in things like combination locks and stuff where I don't want continuous power. Each of these has their own application. You see a lot of different uses for these, particularly in adventure maps. Each one is used kind of in a different way, and it depends on your construction. And as we get into more complicated designs, I'll explain why you'd want a button versus a lever versus a pressure plate. But these are the 4 things to look for. Now we're going to go down the line, go back to these objects that transmit power, and we're going to examine them a little bit more in particular, or examine them a little bit more deeply. In particular, the wires, the torches, and the repeaters. The blocks aren't as important. We can talk about that later. But in order to understand a lot of these different principles when we get to logic gates in the next video, you're going to want to understand how these different objects behave. The first one we're going to address is redstone dust. Redstone dust, it emits power in 4 directions, so we're going to assume it's got power from somewhere, in this case the torch. And I can send power in all 4 directions. I can't get power on a diagonal like this, but if I do this or if I do that, I can send that power on a diagonal. Important thing that most people don't pay attention to is redstone will transmit power exactly 15 blocks from the source. So if the source in this case is our torch, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and on the 16th block, the power dies. And most people, they build a redstone construction and they go, oh my god, it isn't working. Why isn't it working? That's because the power isn't reaching to where it needs to be. So you'd need to add a repeater or some other power relay of some kind. And there's multiple ways to do that, but the easiest way is just put a repeater in the system. And when we say 15 blocks, it means exactly 15 blocks. It's not 15 blocks in a cardinal direction. It is 15 blocks from the source. So if it's zigzagging like this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and again on the 16th block away, the power dies. And I can take that farther out this way, and by the time I get to the 16th block, the power will die. That will happen without fail. This is 90% of the reason most people's redstone doesn't work, is because they don't pay attention to how far the redstone current is going. Once again, that is exactly 15 blocks from the source in this case being our torch. Redstone behaves in a few particular ways. There are a couple ways it can travel and a couple ways it cannot. It can go up 1 block at a time. So if this is my power source and power is coming out of this redstone, and the redstone will come up and over this block and back down the other side, 1 block at a time. It cannot jump more than 1. I have redstone down here, and as you can see, the power does not transmit up more than 1 block. There is a glitch in 1.2 where before you could not place redstone on... Actually, I'm going to go address this later because this is going to be part of this last bit down here. So I'm going to get to that in a second. Normally, and I say normally, redstone cannot jump up 2 blocks and also can't pass through a diagonal like this. If you notice, there's power here, but the power is not being transmitted to this block. That being said, going back to the bug I just mentioned a little bit ahead of myself, in 1.2, and no one's really sure if this is intentional or if this is a bug they plan to patch. Hopefully it's not, because it's kind of handy. redstone will actually, the power will jump through diagonals if it is on glowstone and glowstone only. So if I do this, and we'll apply power here, the power is actually jumping. The redstone doesn't connect like it looks like it should, but you can actually transmit power vertically up diagonals like this if it is on glowstone and glowstone only. The fact that it's only on glowstone makes me think that they're going to patch this bug soon, but maybe not. Maybe this is intentional. And you can use this to transmit redstone power vertically. There are exactly 2 other ways that are guaranteed to transmit redstone without them patching it. The first is the stair-step method, where if I build some stairs, and I can put the redstone on the stairs like this because it will jump 1 block at a time, and then I just apply power at the bottom, and the power goes up the staircase. The other method we'll address later as we get to torches, and it's the alternating torch method, or the vertical repeater method, and we'll get to that in a second. Let's get to torches. Torches create their own power. They're generally speaking the only block that emits a constant output. You could use a lever, and a lever will create a constant current, but it can be turned on and off. If I want something to always be on, you use a torch, and that is about all it's good for. Torches, or at least that's all they're good for in the on state. Torches, when we get to logic gates, and as I get down here, there is a way to turn torches off. And as we address that, that is where torches come into play in logic gates and in large redstone constructions. Most of the behavior of redstone constructions is related to powering on and off of torches and using that to generate some kind of result. Torches transmit power in all 4 cardinal directions as well as up, and they receive power from the bottom. If we move over, as you notice here first, the torch is transmitting power in all 4 directions. I don't have anything above it, so you can't see that, but it does receive power from the bottom. If you'll look over here, this torch is not affecting this redstone in any way. In this first case, the torch is affecting this redstone, it is powering it, but it is not affected by that redstone. In this case, that is exactly the opposite. This torch is not affecting this redstone, but it can be affected by this redstone. If I apply power here, you'll notice the torch here will actually turn off. And this is one of the really useful things about these torches, is we can apply power to them in some fashion like this, and we can turn them off. In this case, this torch is being affected by the redstone in all 4 directions, including directly underneath it, but it is not affecting the redstone. The only blocks it would be affecting are if there were blocks on the same level as this torch and adjacent to it or right above it. And in this case, there are not. If we go over here and we put a torch on the side of a block, it is affecting redstone in the 3 cardinal directions in which it is touching. So it's applying power to this redstone, but it is affected by the redstone, or is receiving power from the redstone behind it. If I apply power here, we'll notice that this torch turns off, much like this one. This is what is called an inverter, and we'll talk about that more on the logic gates. But this is how we this is how we flip signals, and this is the most basic property used in logic gates, is this ability to turn torches off from the back but take power from them in the front. This last application of torches is what's called the vertical repeater method, or the torch stacking method, and this is a demonstration of how the torch will receive power from the bottom and transmit power upwards. So if I go ahead and I'll make a stack of blocks here. Whoopsie. Dropped out a fly. And then we will go like this, and hopefully that lines up properly. And of course it didn't. So if you notice, every other torch is, the odd torches are on, the even torches are off. And then if I take a current up here, this is the most compact way to transmit redstone vertically. The only problem is it alternates. If you'll notice, I can't actually do anything with this level without affecting the one above it. You can only use every other level with redstone, or you have to bring them to the opposite sides. Like if I wanted to use power on this level, I actually have to take it back from the opposite side or out to one of the sides here. as opposed to in the same direction as that one. The other problem with that is this will only be on as long as the bottom one's on, and I can't have power to both of these levels at the same time. The reason this works is, once again, the property of torches to transmit power upwards and receive power from the bottom. So if I can turn this torch off, what I can do is I can actually flip the torch on the top. So as I send a redstone signal on the bottom, it will actually send the redstone signal on the top. You just have to make sure you do it in even numbers. The odd numbered torches here will actually be off right now, and I can't do anything with those torches until I remove redstone power from here, and then that torch will flip on. There is an application for this if you need to set up a puzzle or something in which one door is open, in which while one door is open, another one is closed. You can actually use this in that way. But the odd numbered, or the odd, I guess the, not alteration, the, I can't use my brain right now. I don't know why I can't think of this word. The alternation, that's the word. The alternation of the power is a strict inconvenience, but it is balanced out by the fact that it takes exactly one vertical column. If we look over here, transmitting power vertically with this is really inconvenient because for every block I want to go up, I have to go a block out. The most compact you can get this is a 2x2. And this over here may not stay, but at the moment, this is the most beneficial. This is the least. This construction has the most benefits with the least downsides. The other downside to the torch method is there is a delay. Putting a torch in a system like this, turning torches on and off, adds about a 1-tick delay for each torch it has to pass through. This, however, the stair-step method and the glowstone glitch is, in fact, instant. So as the minute I change this, everything is powered off, whereas when I add power here, you'll notice you didn't quite catch it, but if you'll notice there's just a little bit of lag there. So if you're trying to get timing in certain systems right, this can throw you off. This is really handy. Hopefully it doesn't go away, but, perhaps it might. The last thing we're going to talk about in this lab is going to be repeaters. Repeaters are useful in lots of different applications. The basic properties of repeaters are its single directional reception and transmission of power. It only receives power from the back and transmits power forward. I can't take power from it or give power to it from the sides, from the top, or from the bottom. It just doesn't work. That is both a blessing and a curse when dealing in compact redstone. For example, let me grab a repeater. Where did it go? Did I just skip right past it? Where are my repeaters? Aha, repeater. Okay. Don't need regular torches. With a redstone repeater, let's say I'm trying to send power in 2 different levels, and then I need one set to go up like so. Let's pretend I don't have repeaters. Before, when we just had redstone wiring, I can send power up this step here. But then if I'm trying to run a different line right next to it, they link together. And that's really a pain in the butt. We can do now much more compact redstone with the addition of repeaters because, let's assume I'm getting power from here and then from over here. This redstone is not going to, not like that. What am I doing? This redstone is not going to interlock. And as you notice, I actually do have to put redstone on the same level to get the power to go through. And they're not going to overlap. So let's say I needed to cut power here. I'm not getting any power to there or from there. If I add a repeater here, I can actually... Oh, come on. Should have practiced this a little bit better. But so if I do this, and then I remove, say I don't have power here, this is not going to be affected, and I can use these lines separately for different purposes. So you can make redstone a lot more compact with the addition of repeaters. The other benefit to this particular property of repeaters is the fact that I can actually power multiple objects with repeaters right next to each other. You run into an issue with pistons. Let's grab a piston. If I can find them, and I don't see pistons because apparently I'm blind. Why don't I? Aha, pistons. Alright, so with just redstone wiring, you run into an issue with pistons where if I put pistons like this, and then I do this, pistons are only powered from the back, similar to repeaters. So if I do this, it's actually not going to power any of these pistons. The only way to get these pistons to fire is to send them power directly from the back. There's a workaround with this when I use repeaters. Because repeaters only send power from the back and receive power, or send power from the front and receive power from the back, I can actually power all 4 of these pistons in a line. This is damn useful for a lot of different things. The downside is I don't have individual control, so I can't adjust each of these pistons separately unless there's at least one block of space in between them, and then I can set them to fire at different times. The last thing with repeaters is the tick delay. 1 tick is, I forget how many seconds it is, but it's not very much of a second, and repeaters operate on tick delays. So we're going to assume, let's do it this way, shall we? I will set up 1, 2, 3, not like that, 4 repeaters. Each of these repeaters will be hooked up to redstone, like so. This repeater will have no delay, a 1-tick delay, a 2-tick delay, and a 3-tick delay. And then we will send them power from a single switch, which will be placed right here. And as you notice, when I flip this, when I flip this power, let's let all the power drain, they light up in a line. It's hard to see, but if you pay attention, they light up in a line and they'll lose power in a line. It's snowing in my laboratory. That's not supposed to be happening. Why is it snowing in my laboratory? That's unfortunate. At least it doesn't break redstone. So you can adjust these repeaters for... Go away, snow. Arrgh. This is frustrating. You adjust repeaters for different delays, and you can use that to either delay a reaction on one end, adjust different timings, make certain things fire before other things, or you can use that to make kind of cool things where if I line up a bunch of repeaters, this is mostly just a visual thing, you'll notice that the power transmits down the line. So if I set it up on a pulse, so like if I put a button here, it actually pulses down the line, which is kind of cool. This has more applications in traps and things like that. But if you set it up on a clock, you can get a pulse going down a line, and I had a kind of interesting thought for that for a minecart thing, where there's you can see redstone pulses that show you which direction the track is moving or whatever, which is kind of nifty. But the general idea is that there's a delay between when the power enters the torch, or when the power enters the repeater, and when the power leaves the repeater. That being said, it is the combination of all of these properties that allows us to operate logic gates and create larger constructions. And we'll address that in the next lab. Hopefully you learned something. Hopefully you enjoyed yourself. I enjoyed myself, except for this stupid snow, which is ever expanding as I fly around. And on the note of the blizzard inside my science laboratory, I will leave you there. Hopefully you enjoyed the show. Likes and rates are appreciated, and I will catch you next time.